Okay, this is 4.2, Transformations of Quadratics. We're going to learn, first of all, about the basic parabola. The graph of any quadratic relation is a parabola. Okay, among all parabolas, the main one is the basic parabola, y equals x squared. Okay, you're going to see this parabola for the next 2-3 years in high school. Okay, so you have to be very familiar with it. This is sort of the new version of y equals x, right? Remember, y equals x was just a straight line that moves up like this. Well, now you have y equals x squared, which is a parabola that looks like this. Okay, we're going to see that in a minute. Okay, so just to create that parabola, we'll complete a table of values here and get the key points for the basic parabola. Okay, we're choosing these x values. Again, we've chosen them because we know what the graph looks like. So we've chosen them, we know it goes on either side of 0. So we're choosing negative values of x to positive values of x, increasing by 1. -3, -2, -1, 0, 1, 2, 3. Okay? When we plug that value of x into this formula here, into our equation, we get -3 squared is 9, we get -2 squared is 4, -1 squared is 1, 0 squared is 1, 1 squared is 1, 2 is 4, and 3 is 9. So now if we take those points and we plot them out, -3 up to 9, okay, -2 up to 4, we create this parabola here. And this is the most basic parabola that we start with, okay? All of the sort of functions that you're going to learn in grade 10, we'll start with that parabola, and then we'll move that around based on the values of h and k and a. All right? Any questions so far in this basic shape? All right. Next, we're going to plot the key points and join with a smooth curve. So we know the vertex here is 0, 0 because that's the lowest point. Remember, vertex is either the lowest point or the highest point, depending on which way the parabola opens. Okay, we know the vertex is 0, 0. The direction of opening we can see is upward. Now there should be 2 arrows here because these values don't stop, they keep going. Okay. The axis of symmetry, remember we talked about that yesterday? That is the line that passes through the vertex. Okay, it's in this case, the equation for the axis of symmetry would be x equals 0, right? It's passing right through the vertex of 0, 0. Okay, now finally, the step pattern is the amount that y changes when x changes by 1. This is very, very important because it's going to help you create the graph much quicker. That's why we need to understand what this step pattern is. So the step pattern from the vertex for the basic parabola y equals x squared. What is it? So if we count on this graph here, what we've graphed from the table of values, we can see as we move over x, we move up 1 in y. So that first step is 1. Then if we move over x, we count 1, 2, 3. We're moving vertically by a step of 3. And then we're going to move over 1 again. And we're going to count up 1, 2, 3, 4, 5. So can you guys see this step pattern? 1, 3, and 5. The steps are the y values that we've increased by. Is there any questions at that? How I got 1, 3, 5? Move over 1, up 1. Move over 1, up 3. Move over 1, up 5. Okay? So our step pattern then for the most basic parabola, y equals x squared, is 1, 3, 5. Now if we were to go up another value, so like if I put a 4 here, we went over 1 more, 4, I know that based on this continuing step pattern, which is increasing by 2, 1 to 3, 3 to 5, I know my next one would go up 7. So it would be 7 plus 9. I know it would be 16. Okay, and I can confirm that with the formula y equals x squared. So 4 squared is 16. But do you guys see this pattern here? It's going up 1, it's going up 3, it's going up 5, it's going up 7, the y value. Okay? Okay, hurry up. Let's go, Janae. Any questions there on the step pattern? There's our step pattern. 1, 3, 5, 7, 9, 11. So we're increasing by 2. In Y direction. The washroom? Really? I told you to go before, right? Assuming that you really need to go. Hurry up. All right, here's the key terms. Transformation. It's a change made to a figure or a relation such that the figure or the graph of the relation is shifted or changed in shape. Transformation. So you are moving, changing the shape. That is a transformation. Types of transformations. So there are stretches, which are also known as expansions or compressions. Okay, so if your A value, if you have a value for A, you are either going to stretch or compress that curve. Reflections, which will reflect either in the y-axis, like this, or in the x-axis, like this. Okay, so we have those transformations as well. And translations. Translations are fancy words of like just saying shifting. So the shape is the same, you're just shifting it. So shifting up, down, left, right. Okay, those are all the math words we have to understand. So a translation, a transformation that results in a shift of the original figure without changing its shape. That's what I just mentioned. And then we have a vertical, a shift up, or a horizontal, shift left to the right. A vertical translation. This is part B. Okay, it says graph the relation y equals x squared plus 1 and y equals x squared minus 4 on the same set of axes. Okay, it says use colors. I'll see if I can highlight, maybe. Let's see if I can highlight. Okay. So x squared plus 1. Anyone have an idea what that plus 1 is going to do to our graph? Jadain? You're right, it's going to shift it up. That's correct, yeah, you're going to shift the graph up. So this y equals x squared, that's the very basic parabola right here that passes through 0, 0. So this one here, in color yellow, it's going to be this line here. Okay, it has shifted the values up 1y. So everything has moved up 1. Okay, now when we plug in these values here, you just plug it in for x, so you get x squared is 9, plus 1 is 10, x squared is 4, plus 1 is 5. So you get these values here. Right, so those are the values of the yellow parabola. Okay, now if we have minus 4, what's that going to do, Teodi? What do you think that minus 4 will do to our graph?
Shift the parabola.
Yeah, it's going to shift it, what?
Downward.
Yeah, down 4. So this graph here, that is our new values. And we can get those values by plugging in our x values into this formula up here. Now, an easier way to graph this without doing a table of values, does anyone have any idea how you could have graphed this without having to plug in all those points? Let's assume that you knew this graph. This is y equals x squared. Let's assume that you knew this, because you're going to memorize this over and over again. Start at 0, 0, over 1, up 1, over 1, up 3, over 1, up 5. Boom, you get your 3 points. The same thing the opposite way. Over 1, up 1, over 1, up 3, over 1, up 5. Let's say we had this graph. How could we graph this equation without doing a table of values? Yep. Yeah, that's all you would do, right? You would just take these points here, these individual points, and you would shift them the way that k is going. So in the first one, we would plus 1 on each one of them. Take this point, move it up, take this point, move it up, take this point, move it up. And on the second one, we would take each point and we would move it down 4. That's what we would do. Okay? All right. So what are the coordinates of the vertex? So for this one, x squared plus 1, we need to find the vertex. So we're going to go and look at the yellow graph up here. And we're going to see that the vertex is in fact 0, 1. Okay, this is the vertex right here. What is the step pattern from the vertex? So if I go here and I check the step pattern, over 1, up 1, over 1, up 3, over 1, up 5. So 1, 3, 5 is our step pattern. For this equation here, x squared minus 4, our vertex is going to be 0, negative 4, which is right here. It's the lowest point. Okay? And our step pattern as well is going to be the same. Over 1, up 1, over 1, up 3, over 1, up 5. So that's our step pattern there. All right. So what is the conclusion here? Our vertical translation does or does not change the step pattern from the vertex of the basic parabola. We can see here the step pattern is the same from the basic parabola. So our vertical translation does not change the step pattern. What will change the step pattern? What value? Excellent. The A value. Very good, Junior. The A value is going to change our step pattern, right? We saw in that video, when the A value changes, you're either going to stretch that parabola or you're going to compress the parabola. Okay, so we should see an example of that. Maxis, are you listening to the lesson or what are you doing exactly? Sorry? What are you doing, test 3? Did you not, were you here yesterday to write?
I went, but I used the lesson really important, so I didn't do it.
Okay.
Maybe do it now.
All right. Every lesson is very important. To graph y equals x squared plus k. So what we do, if k is greater than 0, then we're going to vertical translate k up that many units. If k is less than 0, then we're going to translate it down. So k is negative, moves down, k is positive, moves up. Pretty straightforward. Any questions there? All right. Horizontal translations. We did the y first. The video did it second, but we did it first because it is a little simpler. When we translate horizontally, remember we have to reverse this sign. So this is the only part really that gets confusing. Okay? So here we're doing the same exact idea. We're starting with our parabola that is centered at 0, 0. That is the vertex. We're going over 1, up 1, over 1, up 3, over 1, up 5. We get this vertex. And then we're going to make a shift negative 6 in the brackets. Okay? Now we know that the sign is the opposite of the direction that it goes, okay? So if this is negative 6, the actual graph is moving to the right 6. This is x minus 6 squared. That's the yellow graph, okay? What was the question?
I was asking if you would go over 6 of them.
Yeah, you just move all the points over 6. So this 0, 0 comes to 6, 0. This point, and then you could just move the vertex and repeat the step pattern. Okay? Because the k value and the h value will not affect the step pattern. It only translates the graph. It doesn't transform the graph. That's the language we're looking for. Transform, change the shape. Translate, move the shape. Okay? All right, so this graph here with plus 4, remember it moves the opposite way, so plus 4 is actually going to move the graph to the left 4 units. So we get this green graph over here. Any questions there, how we got those two? Now you could do the table of values and calculate the y value based on the x and plug each one in, or the easier way is you just take your original parabola, which again you're going to memorize, 0, 0, over 1, up 1, over 1, up 3, over 1, up 5, and then you just change that vertex and repeat the same step pattern. That'll get you your points much quicker. Okay, so what are the coordinates for the vertex for the -6? Well, we can just look at it here. It's 6, 0. And for the x plus 4, it's -4, 0 over here. Those are our vertex. What's the step pattern? We've talked about it now multiple times. It's the same, 1, 3, 5, 1, 3, 5. Okay, so our conclusion is the horizontal translation does not change the step pattern. Same as vertical translation, doesn't change anything. Okay, now it says to graph x minus h squared, if h is greater than 0, then it moves horizontal translation to the right. Okay, so even though the equation will show a negative value here, that's happening when h is positive. Okay, because when h is negative, what happens is this negative sign goes negative, negative, and you get plus h. Okay, so that's the only confusing part of this really so far. This is the first confusing section we've gotten to. Okay, when h is positive in the formula, it looks negative because it has a negative sign. When it's negative, it goes positive. Okay, so when h is less than 0, we have a horizontal translation to the left, but the formula shows a positive value there. Okay, it's actually a negative, negative h, right? See that? All right. So an example here. Write the equation for the quadratic relation that results from each transformation. So the graph, this is our standard parabola starting at 0, 0 as its vertex. It's translated 7 units upwards. So if it's going to move 7 units upwards, what is the formula going to be here? What's the formula when we move 7 units upwards? Douglas, I'll help you out. Y equals
Y equals x squared plus k.
Yeah, and what's k if it's moving 7 up?
7.
Yeah. Next one, RC. The graph x squared is translated 11 units downwards.
Y equals x squared minus.
Yep. Okay, Jaden. The graph x squared is translated 23 units to the left.
Y equals x. You said to the left.
Yeah.
Plus 23.
Yep.
Bracket.
Very good. Excellent. So he did that in his head, right? It's moving to the left, so we know that h is equal to -23, and we know from the formula of x minus h squared that it would end up being minus 23 squared, so we get x plus 23 squared. Very good, Jin. Excellent. Okay. Finally, it's translated 17 units to the right. Rudy, y equals?
Bracket. X subtract 17.
Very good. You got it. They all look correct. Okay. Good time, good time. We're going to get some time in here for homework. I hope. 14. Sorry, page 4, I mean. Part D. Graph the quadratic relations y equals x squared and y equals negative x squared. So now we are finally fiddling with the a value. Okay, a value in this case is -1. Okay, we don't show the 1 here. Obviously, when it's a 1, we just don't put it there. Okay, so what happens when we have a negative value for in front of the x squared is that you don't square that negative sign because it's outside of x. So we need to substitute in x separately from that negative sign. So it's negative 3. It would be not negative 3, but you'd have to deal with the negative 3 squared first. So it's tempting to say that this is going to be positive 3 squared, which is positive 9. Be very, very careful with that. Because with BEDMAS, we know we have to deal with the brackets and the exponents before we deal with the multiplication. So because, a lot of you guys are going to make this mistake. Because I have a negative sign there, I do not sub in negative 3 into x and get positive and then square it. You have to sub it in like this. See how it gets negative 3 squared first and then the negative sign goes? So this becomes equals to negative, and then the negative 3 times negative 3 is positive 9, so the whole thing equals negative 9. Does it make sense? Is there any questions there? That part's kind of confusing. You really got to pay attention to that, especially if you're not familiar with how negative signs work and squares. This is going to get confusing real quick. Here we're dealing with negative 2. Again, it goes inside the brackets, gets squared, becomes positive 4, and the negative sign goes in front of the positive 4, so it becomes negative 4. All right? Do the same thing with the 1, and then when we get to positive values, it's a lot easier. You just plug in the value of 1, so you would get negative 1 squared. Actually, this is a little confusing as well. So it's not negative 1 squared, it's negative and then 1 squared, which is negative 1. Right? So it's a difference. There's the difference between this and this. That's the difference. You are plugging in the x value first, squaring it, and then adding the negative sign. It's a little bit confusing. Please don't mess that up. Be very careful. Looks like this. Same thing. Negative, you're dealing with the 2 by itself squared, negative 4. And the last one. All right. So what's the coordinates of the vertex for y equals x squared? We know it's 0, 0. That hasn't changed. When it's negative x squared, it's still 0, 0. And we know that because when we substitute in 0 for x, we're going to get negative 0, which is still 0. So we get 0, 0. So the vertex actually doesn't change. The direction for the opening, we know, changes because this is our positive x value, and this is negative x value, right? Okay, so we know it opens up when it's positive, when x is positive, and we know it opens down when x is negative, or sorry, a is negative and a is positive. What's the step pattern? It's 1, 3, 5, same thing. For when it's negative, it's negative 1, negative 3, negative 5. You're going over 1, down 1, over 1, negative 3, over 1, negative 5. Any questions on this example? No? Okay. E, expansion and compression. Finally, now we are going to deal with changing the actual a value, not just the sign, but the value. So in the first case here, we're changing the value to 0.5. So now because the a value is between 0 and 1, we have this compression happening. Okay? If it's higher than 1, we have a stretch happening. It gets skinnier. If we have a compression happening, it gets wider. All right? So here it's 0.5, so we have a wider looking graph. You're going to see if we substitute in this negative 3, again, you need to be careful. The negative 3 actually gets squared. So the whole value, negative 3 squared is 9. So you get 0.5 times 9 is 4.5. Here you get 0.5 times 4 is 2. Here you would get 0.5 times positive 1 is 0.5. Again, we're subbing these x values into this x value here. You get these values, we graph those values, and we get this graph here in yellow. Okay. Now we can start to see that there's a different step pattern happening. Okay, we're going over 1, but we're not going up 1. We're actually only going up a half here. Over 1, not up 1, but up, not up 3, but up 1.5. Okay, so we're going to talk about how the step pattern changes, but before we do that, let's look at this y equals 2x squared, which is this green graph. This green graph, so this one here. Again, I'm taking my x value, I'm subbing it in for x, I'm making sure I square it so it becomes positive. Negative 3 squared is positive 9. 9 times 2 is 18. 2 times 4 is 8. 2 times 1 is 2. 0, 2, 8, 18. Those are these points here. Point, 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 and this point. Okay? So if we graph the relation 0.5x squared, that's what we get in yellow, is wider or narrower than y equals x squared? Is it wider or more narrow? Jafet. Yellow graph. This graph here. This is y equals 0.5. Yeah, so it's wider. Graph the relation. How about the green one? RC? Is it wider or narrower than the black one? Sorry? Narrower. And then the step pattern for y equals 2x squared is actually you multiply the regular step pattern of 1, 3, 5 by 2. So our step pattern becomes 2, 6, and 10. Okay? The reason the step pattern is so important, and why I keep talking about it, is it makes your life so much easier when you're graphing. If you know the step pattern, which you should all have memorized, 1, 3, 5, and you're going to find out in a minute that if you have a changed a value, you just multiply the step pattern by a. So that's how your step pattern changes. Here a is 2. I'm going to multiply 1, 3, 5 by 2, 2, 6, 10. Here the a value is 0.5. I'm going to multiply the step pattern by 0.5. So instead of 1, I get 0.5. Instead of 3, I get half, which is 1.5. And instead of 5, I get half, which is 2.5. Now, if you know the step pattern, all you need is the vertex, and you can get all the other points by just going over x, going up the step pattern. So over 1, up 1, over 1, up 3, over 1, up 5. That's the step pattern. Okay, now your a value is 2, over 1, up 2, over 1, up 6, over 1, up 10. Does it make sense? The step pattern that I'm teaching you is not something that's in the textbook. It's a shortcut. It's very, very valuable. I'm pretty sure the textbook does not mention this. But it makes your life so much easier. You don't have to do this big table, and you don't have to worry about the algebra too much with the negative signs, right? If you know the direction that it opens and you know the step pattern, you're kind of off to the races in terms of graphing it. All right. 5. This is the last page, 5. Is there 6? 5, yes, last page. Here we go. We're going to finish. Exciting, exciting times. Here, y equals 2x squared. We have our step pattern here, okay? Because a is 2, you're going to multiply the step pattern by 2. So we're going to get 2, 6, 10. So over 1, up 2. Over 1, up 6. Over 1, up 10. Okay, so very quickly then, we can graph this y equals 2x squared, just with the step pattern, 2, 6, 10. Likewise, if our a value is a half, we can then multiply the step pattern 1, 3, 5 by a half, and we get 0.5, 1.5, and 2.5. So now we just need our vertex, which we can calculate by just putting in 0 for x. We get 0, 0, And now we go over 1, up a half. Over 1, up 1.5. Over 1, up 2.5. So these are the 3 points that we would have. You can continue that pattern, right? Just continue to multiply it by the step pattern. Remember, the step pattern is going up by 2's every time. Any questions on either of those graphs? Here we go. Your general rule. When y equals x squared, your a value is 1. Your step pattern is 1, 3, 5. When y is negative x squared, your a value is negative 1. Your step pattern is negative 1, 3, 5. When y value is a value is 3, your step pattern gets multiplied by 3. So you go 3, 9, 15. When y value is 0.1, you multiply 0.1 times your step pattern. So these are your new steps. When their y value is 0.2, negative 0.2, oh, we don't have one here. What would I do with my step pattern here? Yep, Adrian?
So it'd be 0.2, 0.6, and 1.
Yeah, so you're going to take negative 0.2 and you're going to multiply it by 1, 3, 5. So you said negative 0.2, negative what?
Negative 0.6.
Yep, and
Negative 1.
very good. Okay. Finally, so in general, when y equals ax squared, a is multiplied by your step pattern 1, 3, 5. So you get 1a, 3a, 5a. That's how it works. If you were listening today, you're going to be in such a good place next year. You know how to do, you know all about y equals x squared. This is like literally ground zero for understanding the foundations for the next 2 years. It's like I'm teaching you here y equals mx plus b, or linear relations, if you will, for all of grade 9 and 10. All right. Finally, note the step pattern shows up as the first differences in a table of values. Okay, that's interesting. So if we were to take table of values all the way back over here, you will see that step pattern, as I mentioned, here, this minus this, this minus this. This is our step pattern. It's also the first differences. All right. Now, to graph, let's cover these answers up and we'll do this quickly together. So, to graph y equals ax squared. If a is less than 0, then kg what? You're going to describe what's happening to the parabola. If a is less than 0, then what is the parabola doing? Nope. If it's less than 0, so I'll phrase it another way. If a is negative, what's the parabola doing? Yeah, it opens down. That's the answer I'm looking for. Okay? So parabola is reflected in the x-axis, or in other words,